Hello everyone, welcome you all to AI Ki Pathsala. In the last lecture, we have looked at how to write a recursive pattern for any given problem in 3 steps. As an example, we have used factorial of numbers. Now here, we look at different mathematical problem, which is Fibonacci number. And by using our 3 steps, we will create a recursive method to calculate Fibonacci numbers. So before starting to write our function, let's clarify Fibonacci sequence. Fibonacci sequence is a sequence of numbers in which each number is the sum of two preceding numbers and the sequence starts from 0 and 1. The typical Fibonacci number sequence will look like this. As you see, the sequence starts from 0 and 1. This means that the first two elements of the Fibonacci numbers are always reserved for 0 and 1. So the next number is the sum of preceding two. Here in this case, 1 is the sum of 0 and 1. And the next number is 2. 2 is the sum of 1 and 1, which is equal to 2. You continue, the next number is 3 here, which is the result of 1 plus 2. Then it goes like this. So here we have 5. 5 is the sum of 2 and 3. As you see, each number is the sum of preceding two numbers, and this is the logic behind Fibonacci number. So hopefully you understand the logic of Fibonacci numbers. Now let's see how we can calculate Fibonacci number for any given number using recursion. As a first step, we need to define our recursive case. So if you look at the sequence over here and take a number from this sequence, we can easily define the recursive case. For example, if we take 5, we see that 5 is the result of two preceding numbers, which are 2 and 3. So based on this logic, we can create a recursive case. So our recursive case for these Fibonacci numbers will be like this, which is Fn is equal to f of n minus 1 plus f of n minus 2, which means that in this case, 5 is n. So here, f of n minus 1 is 3 and f of n minus 2 is 2. Taking into account that we are not just summing the numbers, we are taking the result of these functions. So based on this condition, we can write our initial version of a Fibonacci function. So let's switch to Visual Studio Code. So here I have opened my Visual Studio Code. First of all, I am going to make one file by the name Fibonacci.py. This is the name of my file. Now I am going to write my function over here in this file only. So let's write the initial version of our function. Def Fibonacci n, past n over here, return Fibonacci n minus 1 plus Fibonacci n minus 2. Fine. So this is the initial version of our function. So if you run this function for any given number, let's say I'm going to run it for 5. So let's call this function Fibonacci for, let's say, 5. So let's save this code and let's run it. So after running this function for 5, we see that we receive maximum recursion depth exceeded kind of error, which means that our function keeps calling itself without stopping, which is the infinite loop. So this will lead to system crash if implemented in an application. To prevent this case, we know that we have a second step in which we define a base condition for our method. So let's look at the base condition. So how can you define the base condition for this method? To find out what will be the base condition, let's go back to our definition. Here in the definition, we see that our sequence starts from 0 and 1, which means that if we select as a parameter 1, the Fibonacci of 1 will be 1. If we select as a parameter 0, the Fibonacci of 0 will be 0. This means that we can use 0 and 1 as a base case. So here when we reach these base cases, we will return them itself. So let's again go back to our Visual Studio Code. So here I will write my base condition. So let's write a base condition. If n in 0, 1, return n, else return this. Let's write a print statement to see the output here. Fine. Let's save this code. Let's clear this here. Fine. Now, if I run this function one more time for, let's say, 5, let's see what I'm getting. Can you see? I'm getting 5. The Fibonacci of 5 is 5. Now, when we run this function for, let's say, 6. So let's run this function for 6. Can you see? I'm getting 8. So this 8 is the 6th number in the Fibonacci lists. Here we see that starting from 0. So if I will index them, it is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and it goes like this. The 6th element is 8 here. The 7th element is 13 here. The 8th element is 21 here, and so like this. So if we run our method with 7, we will receive 13. So let's check it. So if I will put 7 here, and if I save this and run this, we should get 13. And if I run this for, let's say, 8, then I shall get 21. Let's run this. So I am getting 21. Now everything seems all right. And we created base condition for our function. So our function works very well. So here we need to do the third step. But before going to third step, I want you to pause the video and think about it. What will be the third step? What is the bug inside this code? Let's see in which situation our function might run into an infinite loop. From the definition of Fibonacci sequence, we know that it starts from 0 and 1. And this is applicable only for positive integers. So here again, we need to take into account that the number is not negative and it has to be integer. So as an unintentional case, we need to check these cases because we didn't take into account that the parameter might be negative or not an integer number. So let's switch to our Visual Studio Code and check these cases. Let me first clear this output. Now, if I run this function with, let's say, -1, save this and run this function. Can you see I'm getting an error which says that if I run this function with -1, you see that again I am receiving this error which says that our function is in infinite loop. So it reaches maximum recursion there. Then Python automatically stopped our loop. So let's run our application for non-integer number. So let's put any non-integer number here. Let's say I'm putting 5.5. Let's save this code. And let me first clear this drawing so that you can see clearly. And let's run this. Here again, I see that I received the same error, which means that there are some cases in which our function will run into infinite loop. So to prevent this case, once again, we need to check the case that the number should not be negative and it must be integer. So we already did this in previous lecture. We will use assert method for Python. So let's use an assert method here. Let me write assert n greater than equal to 0 and int of n is equal to n, and then Fibonacci numbers cannot be negative number or non-integer. Fibonacci number cannot be negative number or non-integer. Fine. Everything else will remain the same. Fine. Let's clear this output first. So if I save this and if I rerun this function for this case, let's say 5.5, let's see what I'm getting. We see that we received different error in this case. I'm getting an assertion error. Fibonacci numbers cannot be negative or non-integer. The same error that I have given it here. So if I run this function for, let's say, any negative number, let's put any negative number. I am putting -7, let's say, and save this code. And let's clear this. And let's run this. Again, you can see I'm getting an assertion error. Fibonacci numbers cannot be negative or non-integer. Now let's run it for any other number. Let's say I'm running it for 13. Let's save this and let's clear this first and then run this. Can you see I'm getting this number 233? Let's run it for some number like say 7. Save this and see what I'm getting. Can you see I'm getting 13? Let's run it for 8. Let's run this for 8. Save this. So I'm getting 21. Everything is fine here. So with this, our function is working properly. So here we showed that how can we create Fibonacci function using recursion. And we took into account our base condition. And also we prevent the cases that might cause our function to run infinitely. This is all for the day's lecture. See you in the next session. Keep learning. Keep